Like the majority of the systems on the A320, the air conditioning system is fully automatic and is designed to provide a comfortable atmosphere in which to work and travel. We will begin our study of the system by first looking at the air conditioning packs. The A320 is equipped with two air conditioning packs located in the wing root area forward of the landing gear bay. Let's look at how a pack works. Hot bleed air enters the pack via a pack flow control valve. The purpose of this valve is to adjust the flow rate through the pack. The air then passes through several stages within the pack that progressively cool the air to provide a conditioned air output. Sub-zero temperatures can be achieved. Two of the stages are heat exchangers that use a flow of ambient air over them to cool the hot bleed air. This flow of air enters via a pack inlet scoop and exits via an outlet duct. So that the output temperature of the pack can be adjusted, a bypass valve is fitted. This valve allows warmer air to be mixed with the cold air. The pack flow control valve and the bypass valve are regulated by a pack controller to vary the flow rate and the output temperature. The pack controller also controls the inlet scoop and outlet duct to vary the amount of air passing over the heat exchangers. Note, to avoid ingestion of foreign matter, the inlet scoop and outlet duct close temporarily during takeoff and landing. To make things simpler, let's define the area within the yellow box as a pack. The two air conditioning packs operate automatically and independently to provide cool, conditioned air. The conditioned air from the packs is then fed to a mixing unit. In case of failure of both packs, ram air is provided via a ram air valve. We will look at the use of ram air in the abnormal operation module. Various pack parameters are monitored by ECAM. They are pack flow, compressor outlet temperature, bypass valve position, pack outlet temperature. These parameters, along with the valve positions, are displayed on the upper part of the ECAM bleed page. Having discussed the air conditioning packs, we will now look at how temperature and flow regulation is achieved throughout the aircraft. The three outputs from the mixing unit feed three separate aircraft zones: cockpit, forward cabin, and aft cabin. Let's look at how the temperature of the zones is managed. A zone control computer monitors the temperatures of the three zones and sends signals to the pack controllers to set the air temperature delivered by the packs. Normally, cold air is delivered by the packs and is then sent to the three zones. Since the different areas of the aircraft may require different amounts of cooling or heating, hot bleed air can be added via trim air valves to obtain the demanded temperature for a zone. In the example shown, no hot air is being added to the cockpit zone. Some hot air is being added to the forward cabin zone, and a lot of hot air is being added to the aft cabin zone. The trim air valves are supplied via a hot air valve. The purpose of this valve is to regulate the pressure of the hot air supplied to the trim system and to act as a shut-off valve. The hot bleed air is supplied to the hot air valve downstream of the pack flow valves. This means that if the pack flow valves are closed, there is no air supplied to the trim system. The hot air valve and the trim air valves will automatically close. The trim air valves and the hot air valve are controlled by the zone control computer. Zone duct temperature, which is the temperature of the air entering a zone, and the actual zone temperature are monitored by the zone control computer and presented on ECAM. The ECAM COND page contains zone temperature and trim air system indications. The ECAM cruise page also contains zone temperature indications. On the overhead panel, the air conditioning panel allows the pilots to control the air conditioning system. Let's look at this control in detail. The pack push-button switches control their associated pack flow control valves. In this example, Pack 1 push-button switch is selected off. The corresponding valve is closed. Pack 2 push-button switch is selected on. The corresponding valve is open. The pack flow selector permits selection of the desired pack flow. We will look at the use of this selector in more detail during the normal operation module. The guarded ram air push-button switch controls the ram air valve. In the example shown, the ram air valve is closed. The use of this push-button switch is restricted to abnormal conditions that will be discussed later. The hot air push-button switch is associated with the hot air valve. In the example shown, the valve is open. Now let's look at the temperature control. The zone temperature selectors are used to adjust the required temperature for an associated zone. Two cabin fans are fitted to reduce the bleed air requirement and therefore save fuel. These fans establish a recirculation flow of air from the 3 aircraft zones to the mixing unit. In normal operation, there are no ECAM indications associated with the cabin fans. The cabin fans push-button switch on the ventilation panel controls the cabin fans. This push-button switch can be used to switch the fans off in response to ECAM procedure.